and welcome to my YouTube channel Civil Line. Myself Milan Patel, Assistant Professor at LJIET Institute of Engineering and Technology. Today's topic is about leveling survey. This is the fifth lecture of this topic. In previous lecture, we have discussed how to calculate RL using HI method and rise and fall method, and also discussed about various examples of computation of RL using HI method and rise and fall method. In today's lecture, we will cover introduction of contours, characteristic of contours, and various applications of contours. Let's start with introduction of contours. In introduction of contours, we will understand these three terms: contour or contour line, contour interval, and horizontal equivalent. First, we will understand about what is contour or contour line. Contour may be defined as an imaginary line which passes through the points of equal RL. What is RL? We have discussed in the previous lecture. It is the vertical distance of the point from a datum line. Okay, so the imaginary line which passes from the equal RL points is called as a contour line. Okay. It can be also defined as the intersection of level surface with the surface of the earth. Okay, it is a representation of vertical distance in 2D maps. Okay, it shows the topography of the area in 2D map. Okay, this is how the contour map looks like. These green lines are the contour lines which connects the points of equal RL points. Okay, and for example, a contour of 80 meter, you can clearly see in this figure, connects the points having the RL value of 80 meter. Okay, so this is how we can draw the contour line. Okay, next term is contour interval. So contour interval is the vertical distance between any two consecutive contour lines. Okay, this is called as contour interval. Suppose number of contour lines are prepared, okay, at number of levels. This vertical distance between two contour lines is called as contour interval. It depends on three factors: nature of the ground, scale of the map, and purpose of the survey. If the nature of the ground is flat, contour interval should be selected as 0.25 meter, 0.50 meter, or 0.75 meter. For steep slope, contour interval should be around 5 meter, 10 meter, 15 meter. For small scale map, it can be 1 meter, 2 meter, or 3 meter. In large scale map, it should be around 0.25 meter, 0.5 meter, or 0.75 meter. For purposes like highways and railways, contour interval should be selected as 2 meter. And for purposes like earthwork, building site, or dam, contour interval is selected as 0.5 meter. Okay, so it is basically depends on these three factors: nature of the ground, scale of the map, and purpose of the survey. Okay. Next term is horizontal equivalent. This is the contour map of a pond, okay, of above figure. Okay. What is horizontal equivalent? This is the horizontal distance between any two consecutive contour lines. Okay, so you can clearly see the horizontal equivalent. It is not a constant value. Okay, contour interval should be constant for the survey work, but horizontal equivalent cannot be constant because of the ground conditions. It varies on steepness of the ground. If the steepness of the ground is more, the horizontal equivalent will be less. If there is a flat ground, the horizontal equivalent will be large. Okay, that's all about introduction of contours. Now let's move to the second topic of today's lecture, which is the characteristics of contours. Okay, so what is the characteristics of contours? There are the points to be remembered while contouring or while preparing a contour map. First point: all points on a contour line have same RL. This is also discussed in the definition of contour lines. The contour lines should be indicated like this, okay, or like this. This 100 value gives the RL of this contour line. Okay, so this contour line connects the point of RL 100 meters. Okay, this is how contour line can be represented in the maps. Second, contour lines always form a closed circuit, but these lines may be within or outside the limits of the map. Contour line must close itself but cannot end on the plan. Okay, suppose there is the plot boundary having rectangular shape. Okay, and we have to prepare contour map for this plot. We are drawing one by one number of contour lines, but last line is out of the plot, but we have to close that line also to prepare the contour map of this plot. Okay, this is given in the second point. All contour lines form a closed circuit. Okay. Third, uniformly spaced contour lines indicate uniform slope. If you see number of contour lines having equal distances between them, okay, like this D, okay, it indicates uniform slope. Okay, there is no unevenness in this slope. Okay. Fourth, contours do not have sharp turning. These contour lines do not have sharp turning. If there is a sharp turning in contour map, means there is a problem in reading. Okay. Fifth, closed contour lines with higher values inside indicates hill. Okay, here you can see the values are increasing because the level of the hilltop is more than the foot of the hill. Okay, so the values of RL increasing from outside to the inside, which indicates a hill. Okay, if the values of contours are decreasing while going inside, like 100 meter, 95 meter, 90 meter, 86 meter, values are decreasing. It indicates the valley or a pond or a depression, you can say. Okay. Next, contour lines are closer near the top of the hill and wide apart near the foot. This indicates a very steep slope towards the peak of the hill and flat slope towards the foot of the hill. Where there is a steep slope, the horizontal equivalent is less. We have just discussed in the term horizontal equivalent. Where there is a steep slope, the horizontal equivalent will be less. Where there is a flat slope, horizontal equivalent will be more. Okay, so that principle is applied to draw the contour lines. Okay, so contour lines are closer near the top of the hill because there is a steep slope, and where there is a steep slope, horizontal equivalent will be less. Okay, and the contour lines are far from each other because of the flatter slope. Because in flatter slope, the horizontal equivalent will be more. Same way, contour lines are closer near the bank of the pond because at the bank of the pond, the slope is steep and wide apart towards the center portion of the pond, because at the center portion of the pond, the slope is gradual or flat, and at the flatter slope, horizontal equivalent will be more. So the contour lines are far from each other at the center portion. Okay. Next is contour lines meeting at one point indicates a vertical lift. You can clearly see this vertical lift. All contour lines are meeting at one point. Okay. Next, two contour lines never intersect with each other except overhanging cliff. Okay, this one case is the exceptional one. Okay, in all other cases, two contour lines never intersect with each other. Okay, here in overhanging cliff, one portion is overhanging. Okay, the top portion of the hill is overhanging from the bottom portion. Okay, so the contour lines are intersecting with each other. Here you can see the contour line of 250 meter and 200 meter are intersecting with each other. Okay, this intersection of contour lines is only observed in overhanging type of cliff. Okay, and the last is contour lines deflect at valley line and downhill at ridge line. So what is valley line? You can clearly see this type of shape of valley is there. So this is the valley. If you draw the contour map of this valley, okay, contour lines are like this V shape. Okay, while what is ridge line is the top of the hill, like U-shaped hill. Okay, there is a range of hill like this. Okay, if you draw the contour map for ridge line, it looks like this. all contour lines having the shape of U. So if you observe the U type of contour lines or V type of contour lines in contour map, you can clearly identify that this is a ridge line, this is a valley line. Okay. That's all about characteristics of contours or the points to be remembered while contouring. Okay. Now let's move to the last topic of this chapter, which is applications of contours or where these contour lines or contour maps can be used. Okay. First application is to select the sites for engineering projects such as roads, canals, railways, etc. Second is to find the possible route for communication between two different places. Third is to compute the capacity of reservoir behind the dam and area of submergence due to reservoir. Fourth is to find intervisibility between two stations. We can easily find out by contour lines or contour map. Next is to fix or obtain the profile of the ground surface along any direction. Next is to mark suitable route for a given gradient on map. Next is to estimate the quantity of cutting or filling, because in contour lines the vertical distances or the height of the ground can be observed. Okay, so by estimating this contour map we can calculate the quantity of cutting as well as filling. And the last is to know drainage characteristics of any area and to select the sites for bridges, culverts, tunnels, etc. Okay, this is where contours or contour map is used nowadays. Okay, that's all about this lecture. I hope you all understand what is contour, what is contour interval, what is horizontal equivalent, what are the various characteristics of contours, and where these contour maps can be used. See you soon in the next lecture. Thank you for watching. Don't forget to like, share and subscribe to my YouTube channel, Civil Line. Thank you.